I'm Doug, I work at X24, and yesterday we moved from a horribly maintained rack of physical equipment in a warehouse in Bristol, onto the cloud. There's no good artwork that represents the cloud, so I got a smiling face. Quite stressed, because it was...
Rack, yeah.
What?
The rack in someone else's city instead of yours.
Yeah, hopefully, I'd hope it's slightly better cabled than that, but it's out of sight and out of mind. When we started the project to move, what I had to answer was these kinds of questions. How do we know it's going to work? How can we ensure that when Friday rolls around, like we work in the ticket industry, tickets for some reason go on sale on Friday mornings. That's the big day. So we can be very quiet for the whole week and have something like 6 to 7 times our regular traffic level arrive at 9 AM on a Friday morning. How many users can we handle? We know the old site copes with 2,000 people online, fine. If we're moving to disparate hardware, running with databases that might not be in the same rack, the same warehouse in Amazon, will they be able to talk to each other in the current kind of time frame? Will the site respond well under load? We're running on virtual hardware rather than real hardware. Have we missed anything? We've got an awful lot of legacy pages on the website. You might have told guessed from some of the strange questions I ask people. I can't never remember all the bits of our site, so have I missed packages and tools that are important for these kind of odd things? And also, does our monitoring work? We rebuilt a whole monitoring stack for Amazon, but should my phone go off when the database freaks out? And how do we make sure that when things are actually breaking, that we're going to receive the information that we want? So I wrote tests with Gatling. As opposed to other load testing tools, Gatling cares about users rather than URLs. So a classic load testing tool is Apache Bench, where you give it one URL and it just slams it with as many requests as it can. But it's not a very good test of what your site is actually going to be like and what people are going to do. So with Gatling, you write a scenario, which is what users do, a journey through the site with gaps between the requests. You write the test in Scala, in a sort of domain-specific language. You don't have to know any actual Scala to do it. It uses a thing called the actor model under the hood, which means it can scale really well on one machine. We managed to bring down 2 to 3 load-balanced web servers with just one smaller test machine. You can control the traffic levels very well. So if you want to, you can run load tests against your production website with a very carefully maintained level of traffic to push it up and up and up until you reach almost the breaking point. It's got a test recorder, a proxy that you point your local browser at, you browse around your website, and it builds the test for you. And it creates visual summaries, like a nice browsable, presentable report at the end. So here's the parts of a Gatling test. You make a protocol, you give it a URL, some headers. This is where the recorder comes in really handy. If you were to sit down and write this, I just put the URL in and maybe a user agent and forget about things like accept headers and encoding headers. But they do make a difference if you've got proxies and load balancers in the way. They often care about these things. So using the test recorder means that Gatling captures all of the extra information that your browser is sending. With the user agent, I made sure to not give it a real user agent. And it meant I could go through our code and add conditionals around our monitoring and our logging. So I wasn't sending Google Analytics tracking information for Gatling tests, and I wasn't logging it into an internal database, because I would massively skew the statistics of page views if I were blasting tens of thousands of requests at one particular page. Next, you write the scenario, what's actually going to happen on the site. So this is where the domain-specific language comes in. So this is our PHP Southwest example. I'm going to the home page, waiting for 3 seconds, hitting a fictitious login on the PHP Southwest website. So you can also send post requests. You can emulate anything a browser does. That's not. You don't actually have an account without a password, do you? No. Good. Yep. Yep. So this executes a login test with the parameters. Waits for 7 seconds, makes another request for one of the event pages, waits for 10 seconds, and makes a final request for the talks page. You can make this as long or short as you like. And the last step is the setup, where you inject users into this. So this says, I'm going to have one user that arrives immediately, and then over the next 30 seconds, 10 more users are going to arrive. It's very readable. You can stack these, so then you could add 50 at-once users, a bigger ramp users. You can ramp from 0 to 1,000 over 2 hours, as much as you want. Then run it in the console. This is the output. This is not from the test I just run. This is something a bit more interesting to look at. It gives you all the different categories of URL that you specify, whether they've passed or failed, and you get little progress bars for all the users. When it's done, you get a graphical report. So you get a You get charts that you can give to management types with 80,000 successful requests and nothing that took longer than 800 milliseconds. You get tables full of statistics, if that's your kind of thing, standard deviation, percentile response times. You get more graphs, so this is the response time over the test, and the orange bar shows the number of users who were present. So things like this are some pages take up to 10 seconds to respond, but there's no particular pattern throughout the test. So that just means there's probably some slower pages on the site I should look at. When I was benching things particularly aggressively, you would see green, 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 and suddenly a huge ramp up in red as something broke, the database gave in. And you get another graph of this is the number of requests per second. So this was a fairly limited test. It was only pushing about 100 HTTP requests at the server. This is fine, creating tests by writing them and thinking about what you do. But the most important thing for us was doing log replay. So getting a log of, say, a 9 o'clock on Friday level of traffic and replaying it at the server. So that means as many users as we actually had, visiting the same pages we actually had, in the same time frame that they actually did. So to do this, I got my web server logs, turned them into a CSV, because Gatling can read CSVs natively, and then wrote a script in PHP, which I'd hoped to have ready for this presentation, but because of all the Amazon switchover, I don't have in a shareable format, that analyzes it, finds out how many people did we have on the site at that time, how many requests did they make each, just on average will do, how long did they spend making those requests, did they all arrive at once? Because we've got a lot of timers on the website, it tends to be that at 8:59:59, everyone refreshes the page. So we get a huge spike at once, and then it's a bit quieter for the rest of the hour. And the one thing you can be sure of from reading a web server log is how many requests per second was your current setup handling. So the test looks a bit more like this. So, cut off the end of my slide, the code there. So in Gatling, you've got a thing called a feeder. So you give it a CSV feed, and that word that's cut off says circular. So it means once you get to the end of the CSV, just go back to the start. It doesn't really matter in something like this. And then the scenario becomes a repeat. So it says 6 times, grab the next thing out of the feed and do a HTTP request for it. You can stick the CSV columns into your test and just check that it didn't come back with 500 and wait 40 seconds. So that was something that I was surprised with. Users spend a lot longer between requests than I thought they would. If I were to write the test by hand, I'd say, 10 seconds, by the way I browse around the website. But our real users leave quite big gaps. And the traffic profile looks something more like this. So fictitious numbers, but you can pull out a specific number from the logs to make sure that the traffic profile really matches what you originally had on the site. Something else that I haven't put in this presentation that we did was have a scaling factor for the logs. So I'd take a level of traffic that we knew we could cope with and then play it back at double speed or triple speed or quadruple speed to find the breaking point of the new hardware, of the new setup on Amazon. That was incredibly important because we wouldn't always know how busy the site's going to be, and we wouldn't have examples of the site being as busy as it's ever been. We were busy 3 years ago when Take That went on tour, and suddenly everybody over the age of 30 decided they wanted to see Take That for some reason. But we've not been that busy for a while. So to be able to take something a bit quieter and play it back faster and more aggressively, meant that we could be sure that if that comes around again and someone we haven't thought of gets very, very popular, we know that the site can cope with much higher levels than we've actually seen. Fairly quick run through that. Any questions?
Are the requests distributed, or they all come from a single?
They're all coming from a single IP at that point. So if you have smart load balancing that does geographic things, then you obviously aren't testing that. There are third-party services that host Gatling for you and will spin up geographic instances, but I found them very fiddly. You'd spend a long time fighting the service. And because I could bring down our infrastructure with one thing on Amazon, I did.
What's the biggest difference when compared to Jmeter?
I found, so Jmeter is another popular load testing tool. It can do a lot more than Gatling in that you can write email load tests and it can do lots of protocols. I found Jmeter to be XML-tastic. Everything was XML. If you want to do complicated things, you'd have to open up your XML editor and start nesting nodes. And I found this kind of Scala DSL much more readable. I think Gatling has better scaling. As far as I understand it, this might not be correct, that Jmeter likes to have one user per thread. So if you want a lot of users on the site, Jmeter needs a lot of threads. It can be quite hard on the test machine, whereas Gatling can get an awful lot more power out of a smaller test box.
So like, if you're doing like a load test on something that happened on Friday when it's busy, do you have to, then you're doing your load test on, reset the data to where it was on Friday? Because like all the tickets are on
Yes, that can be difficult. For some of these things, we run on a fixed database. So we took a snapshot of the database, moved it up onto new servers, and kept it there. If I'm testing the actual live website at a quiet period, I assume that if the log is from yesterday, most of those pages have very similar information on. There is always going to be some divergence, but within a reasonable time frame, you can be sure, certainly with our site, that nothing has changed too drastically.
How do you know that it's not, you know, sort of bottleneck isn't in the machine you're testing from?
It's tricky. I did start running this on my laptop and found that the bottleneck was the Wi-Fi, and then I plugged it into Ethernet and found the bottleneck with the local server. I moved it onto Amazon. You just have to watch for odd responses. So I would crank up the load factor in my test, and if the site responded exactly the same, and I crank it up more and it responded the same, I'm probably not actually benchmarking the site and benchmarking my own machine. The Gatling website does have a very good guide for running it on a Linux box and what kernel parameters to tune, network options you can set, JVM options you can set to make sure that Gatling can absolutely max out the local machine. Then you should be able to watch, say, top or something on the machine that you're running the test and see whether that's working hard. And then you know you've saturated the test box.
I just imagine if you were testing a cluster, it would be almost impossible to saturate the cluster on a single machine. You need the same amount of machines in the cluster to...
Oh yeah, it entirely depends what you're benching. We found our sites runs an awful lot of code on each page request, so the CPU on the web server's maxed out long before the test box. If you're benching something, I guess like Nginx trying to serve a single static file, you would need to make the test machine work very hard. So that's where these third parties come in, where you can just pay them and they'll spin up a Docker container in 20 places all running your same test. But Gatling's, this result is built from a log file, but the log files are just a log of what happened. So you can run it in multiple places, grab the log files, append them to each other, and then have Gatling build the report as if it all happened on one machine.
How annoying is it keeping recorded tests in sync with what the website expects, or how the website behaves?
Do you mean the sort
So like, say you recorded some user behaviour, and then somebody goes and makes a new feature or changes how that feature works.
I would imagine that would be quite annoying. We don't have any tests that have been around long enough to suffer from that. I think that's where the log replay thing comes in very handy, is we could do a regular thing where you say, go off, grab a log file and replay that every day. You can be sure that because the log came from the code as it is, that you are replaying something that should still work. Right, thank you very much.